Because of weather and school delays and who knows what's going on, I made this little video as a review to go with your study guide. It's possible you're going to have to refresh everything over the weekend and be prepared to take the test early next week. So let's talk about electrical circuits. Let's define an electrical circuit. It is a continuous path from a voltage source, like a battery, through a load, like a bulb or an appliance, whereby electrons can flow. Remember that the definition of electrical current is the flow of electrons. There are two situations in which a current can find itself, closed or open. In a closed circuit, the flow of electrons is uninterrupted. There are no breaks in the wire through which the electrons are flowing. So it goes from the battery, the positive end, across the wire, and if there are any loads or switches, they will be connected so that the electrons can flow all the way back to the battery again. In an open circuit, as the electrons are flowing out of the source across the wire, there is some sort of an interruption. In this case, the switch is left open, hence it's called an open circuit. In this case, the electrons quit flowing and can't make it back to the battery because there's been a disconnection. A burnt-out light bulb can also create an open circuit because the electrons wouldn't be able to flow through the filament of the light bulb. Typically, circuits are constructed using conductors made out of metal. A conductor is any material with low resistance. The reason materials with low resistance are used is so that the electrons can flow freely. There are two formations of circuits. Let's start with series circuits. A series circuit has one possible pathway for electrons to flow out of the energy source and back around to the energy source. Anything found on the series circuit is connected. For example, if we have 4 light bulbs arranged on a series circuit, they are all connected by the same wire. The cheap Christmas lights are this type. As the electrons flow out, they have to be able to flow through each light bulb in order to return back to the original power source to illuminate. If, for example, the second bulb were to burn out, meaning the filament severs and the connection is lost, then all of the bulbs in this entire circuit would no longer be illuminated because there's no way for the electrons to continue to flow. If you've ever had an opportunity to really inspect the inside of a light bulb, you'll find that the filament or the wire comes in at the side of the light bulb with the threads, coils around, and then exits at a different point at the bottom of the light bulb. This helps to complete the circuit. The electrons flow in, come in contact at the threads, go through the light bulb, and then exit to complete the circuit going in another direction. Now the filament is important. That's where the resistance comes in, and because of the resistance to the flow of electrons, it heats up, it starts to glow, and that's what makes the light bulb illuminate. Resistors in a series circuit add together for the total resistance. So in this example, if we have a 4 ohm resistor, maybe a 10 ohm resistor, and an 8 ohm resistor, total resistance would be the sum of these, 4 plus 8 plus 10, or 22 ohms. In series circuits, current remains constant throughout the circuit. Resistance adds together. Each resistor might have a separate value, but it adds up to a total value for the entire circuit. Voltage also adds, meaning the voltage coming from the battery is the total, and the voltage at each resistor will be a different number adding up to that total, and likewise with power. Parallel circuits are those with separate pathways, meaning the electrons can leave the battery and find more than one path to return back to the battery again, as long as there are no interruptions to the circuit. If a bulb burns out in a parallel circuit, then the other bulbs are not necessarily affected if they're on separate pathways. It's all about the flow of the electrons. In this case, the first bulb burns out and the flow of electrons stops at that point. However, there are other pathways for the electrons to flow, therefore the other bulbs could remain illuminated. Each bulb on a parallel pathway is independent of the other bulbs. Resistance in parallel circuits diminishes. It's the reciprocal of the sum of the reciprocal of each individual resistor. It's important to remember to hit that last reciprocal key on your calculator to get the final answer. For example, if we have a parallel circuit with 3 resistors that are perhaps 3 ohms, 5 ohms, and 7 ohms, to calculate the total resistance, we would take 1 over 3 plus 1 over 5 plus 1 over 7, and then take the reciprocal of that answer to get total resistance. So in this example, the reciprocal of 0.68 would be our total resistance, which would be 1.5 ohms. Remember that resistance diminishes in a parallel circuit, meaning the final total resistance, in this case 1.5 ohms, is less than each of the individual resistors. It's less than 3, it's less than 5, it's less than 7. The rules are different in parallel circuits. Resistance now diminishes because we're taking the reciprocal of the sum of the reciprocals. Voltage is what remains constant. And current and power each add at each resistor to equal the total. Typical households are wired as parallel circuits so that each room can operate independently. And households typically have a power source of 110 volts coming into the house. We discussed this example in class. It's all about the flow of electrons from one end of the power source through the wire back to the power source again. As long as electrons can flow freely, all the lights will stay illuminated in this particular example. However, it's when certain light bulbs go out that flow of electrons is interrupted. For example, if bulb C or F happen to disconnect because the filament inside is broken, that leg of the parallel circuit cannot function because the electrons can no longer flow. A and D can continue to flow. The electrons can continue to flow through B and E. But when it comes to C, it would stop. If, on the other hand, either D or E were to burn out, electrons have a path through which they can continue to flow back to the battery. Therefore, A, B, C, and F would continue to illuminate even though D and E have burned out. This is the advantage of a parallel circuit. And lastly, we have these combination circuits, where part of the circuit is parallel, but another part of it is series. The strategy is to work out the parallel circuit first and resolve it down to a total resistance, turning it into what would be one resistor in series with the main leg of the circuit. In this case, parallel circuits of 6 and 3 ohms have the same total resistance as one resistor of 2 ohms. So now we can treat the main leg of the circuit as a series circuit having 3 resistors of 10 ohms, 2 ohms, and 4 ohms. From there, we can work out any questions that are being asked about the voltage or the current. It would be important to remember the rules, such as current is constant in a series circuit, whereas voltage is constant in a parallel circuit. Those different rules would affect working out the math throughout the circuit. All right, after this quick review, it's your job to study. You need to study more than just a study guide. That's just a starting place. You need to go and check the other resources that I provided in the Edmodo folder, on the links that I provided in the study guide, our other worksheets, etc. Make sure you're prepared on Monday to take this test. Good luck.